Here's what I've come up with as a position sensor for the direction the shaft is pointing. So what I've done is the center of the shaft that was coming out of the gearbox had a threaded hole down inside. So I took a stainless steel Allen head bolt and put a lock nut on it, and then found a piece of vinyl tubing that slid fairly tightly over that. It has quite a bit of grip, I think. There's no clamping or anything, but I think just the fact that it's just the right size. And then I epoxied the end of the potentiometer, which looks like this. So it's got these grooves on it. It's hard to find an adhesive that sticks to vinyl, but I thought I'd put some of this JB Weld in there. It's pretty good stuff. It's really sticky. Doesn't take any torque to turn these things. They turn fairly easily, so this doesn't need a lot of grip. What it needs is durability. So we'll see how that goes. So let me show you what's going to happen, how this works. So on the top of this potentiometer are 3 connections, and it's on this bracket that is going to be, it's not yet, but it's going to be screwed down to this piece. So this is flexible, and what it does is it allows for the vinyl tubing to take up any discrepancies of whether these are in line with each other. So by having this in here, it gives it a flexible link, which now it doesn't transmit any kind of damage from one piece to the other. So what I need to do now is I need to calibrate the position of this to the position of this. When this is in the middle, which it is now, if you look, I have a line here, and you can see that it's pretty down the middle of it. It's close enough for me. And I want to now take that and position the signal to be halfway. So this is it, and mounted. I'm going to use this one, just a different one to show you what we're looking for, what that means, and then it'll be the same for up here. So I'm going to move this back. So this is a potentiometer. It's a volume control knob. It's anytime you turn a knob on something that doesn't spin all the way around, this only turns about 3/4 of a turn, right? And you can see by that slot there, that's as far as it turns. Okay, and this has been a very common device used to adjust, well, to split a voltage primarily. This is variable resistance. When you turn the knob all the way one way, the resistance is low or high, depending on how you're measuring it. And when you turn it all the way the other way, the resistance goes high or low, depending which way you're measuring it. And what I mean by that is, there's 2 circuits here. There's the circuit between this pin and this pin, and there's the circuit between this pin and this pin. And we're going to put a multimeter on here to show you what the relationship is. But as the resistance value between these two, as it goes up, the resistance value between these two go down at the same proportion, right? So this is like counting down, and this is like counting up on resistance. And the resistance across these two total, right? So the resistance from the in to the out, whatever you want to call it, should match the sum or the total of these two plus these two. So if the whole thing is 10, this is a 10,000 ohm potentiometer, 10K potentiometer. So from here to here is 10,000 ohms. Now I've measured the one I have on there, and it's only 9,000 something, when you actually measure it. So we're going to take that number, and we want to make sure that the value from here to here is exactly half of the value of here to here. That means this is perfectly in the middle. And then once it is, then I can drill and bolt down the bracket for that potentiometer on our servo to say, okay, that's our starting position at 0. We'll be able to tweak it a little bit because that vinyl tubing is only pressed on the bottom. We can probably turn it a little bit if we need to there to tweak it. Or what I might do is the screws that I mount it with, I might put a slot in them instead of a hole, so we can turn the bracket back and forth a little bit. So we can tweak when this value is exactly in the middle between these two values. Maybe more clear when we have a multimeter on it. I'm going to try to find a second multimeter to make this easier, but I'll be back.